Hi everybody, it's just me. I'm going to teach you linear relationships and bivariate data, lesson 5.3 in your books on page 141. So open up and get ready to join me. Today we're going to be talking a little bit about finding an equation when you're only given a graph or a table and you are not given your y-intercept. And we're going to look at a couple of different ways that this kind of data can be shared with us. We can also write linear equations or basic equations when we don't have a linear equation. And I'm going to talk to you a little bit about how those are going to look. So let's start out by looking at example 1. And of course, we want to review the most important thing of the day, which is the format that we want our equations to appear in. So in general, when we are asked to write an equation that is linear, we want to put it into the y equals mx plus b form. So the first example says a handrail runs alongside a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. Show that the relationship is linear, and then find the equation for the relationship. So the first thing that we want to notice here is that it tells us that the relationship is linear, and that's our first major hint that when we graph this information on a coordinate graph, we had better have those points line up in a straight line. Then it asks us to find the equation. So the first thing that we are asked to do is to show that the relationship is linear, and we can visually show that by connecting those points that they have graphed and drawing a line. So I'm going to go ahead over here with a straight edge. I'm going to connect those points and extend my line. Okay. Notice that I didn't extend it into what would be our second or third quadrant because we're talking about a height, and heights can never be negative. So in order to show that a relationship is linear, like I said, we can just graph our data points and connect them with a straight line or sometimes a curved line. In this case, it was straight, and that proves that it is linear. So the second thing is to then write the equation of the line. And in order for us to do that, we need a couple of pieces of information. And we've gone over this in class, that in order to write an equation of a line, we need to make sure that we have all the information needed for the y equals mx plus b format. So really quickly, as a good review, let's make sure that you understand that the b represents the y-intercept. And again, that's where the line intersects with the y-axis, and it's always going to be at a point 0, something. And sometimes that's going to be very easy to identify, and other times it's going to be questionable as to whether or not it's a whole number. So we have to be careful how we approach that. And the second piece of information we need is the slope. And remember that we can find the slope at any time by using 2 ordered pairs. And we can pull those right off the grid or the graph that we're given. So I'm going to go ahead and apply this idea to this chart that we see. And I notice over here that they've labeled all of the ordered pairs for me, which is really nice. It makes this process quick and easy. So the first thing that I want to do is I want to notice here that when I connected those dots, it intersected with the y-axis, but it did not intersect directly at a hash mark. So either my drawing and connecting those dots is a little bit off, or my whole number or my intersection of my y-axis, my y-intercept might not be a whole number. So I can't guess here. I really want to make sure that I'm accurate with interpreting what the b is. So the first thing that I'm going to do then is I'm going to identify what the slope is. So I'm going to go ahead and just pick 5, 7 and 10, 11 to figure out what my slope is. So let's remember that to find our slope, we use y sub 2 minus y sub 1 as our numerator, and we divide it by x sub 2 minus x sub 1. And so remembering that our ordered pairs that I picked are 5, 7, and I also chose 10, 11, I'm going to substitute these ordered pairs into this formula and crunch the numbers to get my slope. So my y values are 7 and 11, and I always choose to put the bigger number in the front for the numerator. It's just my option. And then I'm going to divide that by 10 minus 5. So because I put 11 in front, I need to put 10 in front as well. And 7 from 11 is 4, and 10 minus 5 is 5. So that tells me that my slope is 4/5. Okay, so now looking back at our original equation where I was asked to write it in the form of y equals mx plus b, I already can fill in my m. I know that the m is 4/5, so I get y equals 4/5 x plus b. So I'm halfway there. I've got one piece of the information that I need out of two. So the next thing that I need to do is to be able to determine what my y-intercept is. And remember, by looking at the graph, it's not exact, so I can't just guess and say that that's 4.5 or 4 1/3. So instead what I'm going to do is I'm going to pick an ordered pair. Again, in this case, it does not matter which ordered pair you pick. Any of these ordered pairs should give you the exact same y-intercept. So because it doesn't matter which one I pick, I'm going to pick the easiest one that I could work with, which is the smallest ordered pair, 5, 7. And so because I've chosen 5, 7, I'm going to write that down here to help you guys track what I'm doing. I want to remember in any ordered pair, the first number is my x and the second number is my y coordinates. And so now what I'm going to do is I'm going to take my x coordinate, which is 5, and I'm going to substitute it in over here into my slope-intercept equation. And then I'm going to take my second ordered pair here, which is 7, or my second intercept or coordinate, pardon me, it's a coordinate, and I'm going to substitute it in over here for the y. And so it's going to look like this. I'm going to get 7 equals my slope, 4/5, times my x coordinate, which was 5, plus b. And notice that I've written the 5 as 5/1 because eventually I'm going to be multiplying these two together, and one of them is a fraction, so it's easier to multiply a fraction by a fraction. So now I'm going to go ahead and multiply. I'm going to simplify what I can. My final goal is to try to isolate b, solve for b, so that I can tell what it is. And so I'm going to go ahead and either multiply straight across here or cross cancel. I know 5 goes into 5 once, 5 goes into 5 once. So multiplying straight across, I get 4 times 1, which is 4, and 1 times 1, which is 1, and 4/1 is 4. So when I simplify this term right here, I get 7 equals 4 plus b. And so now looking at this equation, it's pretty easy to see that b has to be 3. If that doesn't pop out at you, remember that you can always approach this as solving a regular equation. To get b by itself, I need to get rid of 4. And the way to get rid of 4 is to subtract it. This would drop out. And 7 minus 4 is 3. Now this might seem a little silly at this point, but sometimes these get a little bit more complicated. So this is a pretty good, valuable lesson for all of us to visually see what happened. I got that my y-intercept was 3. So when I go back here to finish off this equation, I want to write it as y equals 4/5 x plus 3. And that is the equation of this line. Now the reason that I think that's pretty interesting is because if you check this comparatively to where I've graphed it, you can see that it doesn't necessarily look like it's at 3 exactly. So it's not something I could have just guessed. So this is the equation of this line. And there is another way to check it to make sure that I've done it properly. And I'm just going to show you this one time to make sure you know how to do it. And that's to pick any other ordered pair that you've got available to you, and to substitute it into this equation, and you better get a true sentence. If you do not get a true sentence, it means that you've done something wrong in the process of writing your equation. So let's just do a real quick check. I'm going to check to make sure that this is correct, and I'm going to use the next easier ordered pair, which is 10, 11, to check and make sure I did it right. I'm going to remember that 10, 11 is my x, y, and so I'm going to substitute these numbers in the right places. 11 is my y, so it goes in over here. And it's supposed to be equal to 4/5 times whatever my x coordinate is, plus 3. And so now I'm going to follow order of operations and simplify. And 4/5 times 10/1, I can do my cross canceling again. And 4 times 2 is 8, and 1 times 1 is 1, so I get 8. So my question is 11 equal to 8 plus 3? Is that a true sentence? It is. Therefore, I know that I've created my equation correctly. That's the really cool thing about math. You can always check your answers. Even when we get into algebra and writing linear equations, there's still always a way to check and make sure you've done it properly. So this is the correct answer. And what you'll see if you look into the book is that they did not mirror my answer. And I'm sure you can imagine my disdain and frustration when I looked down and saw that they wrote y equals 0.8x plus 3. So what I want you to do in your book is to say, ew, this is not what we're looking for. We would much rather see this written as y equals 4 over 5x plus 3, which is what we found in the first place. Remember, we want our slope to be a guide or a direction, a rise over run, and so we really would prefer not having your slopes appear as decimals. So you can see how we were able to take information that we're given off of a chart or a graph and to write a linear equation with just a minimal amount of information. And we're going to talk a little bit more about that on the next page. So go ahead and turn to page 142. We're going to take a look over here. And so you actually get an opportunity to try these out. And so I want you to pause the video and to give number 1 and 2 a shot and see how you do. And when you're ready, come back and check, and I'll show you how I got the answers that you've already seen, which are y equals 4x plus 20 and y equals 240x. So go ahead and pause it and try it, and we'll see how you did. Okay, welcome back, 8th grade. The first equation should be y equals 4x plus 20, and I did a whole bunch of work here to help support you and show you how to do this. So I would encourage you to pause the video at this point and take a minute to look it over, make sure you did it properly. And if you have any questions, make sure you highlight or identify where they are. So the equation for this one should be y equals 4x plus 20. Just a real quick vision check. This is a positive slope, it's a positive number, and so I want to make sure that my graph is going up, up, and away so that they match, and it is. The second one's a little bit harder to test for slope, but what I do want you to notice is that we've got an increase in my y values. So one way to check to make sure that you've done it right when you've computed your linear equation is to notice that the slope here is positive, and I have an increase going on here in my y values. So that's another indication of a positive slope. And I'm going to show you how I computed that. This is number 2 right here. So I chose 2 ordered pairs, I found the slope, and then I calculated the y-intercept. Again, notice here that I've written it in 2 different ways. I've written the equation in y equals mx plus b form, and I've also written this particular equation in y equals kx form. That's because this is direct variation, so my constant shows proportionality, meaning that this will intersect with the origin. So this would be the preferred equation that you write because it is more simple and simplified than this one. However, they are both correct. Okay, so now we're going to move on to the next section in the book, which is called Making Predictions. And what we're going to do here is we are going to take a look at a little bit more of a complicated problem. This one says the graph shows the cost for taxi rides of different distances. Predict the cost of a taxi ride that covers a distance of 6.5 miles. And so what they've given us is this chart, this graph to look at to try to figure out that information. And so what they are asking us to do is to predict the cost of a taxi ride that covers 6.5 miles. And so what I need to do is I need to look down here at my x-axis and notice that that's a distance. And so the first thing that I want to try and do is to identify my interval. So I know that from 0 to the first numbered hash mark, it's 4 units. So that means half of that has to be 2. And then I can number across. 2, 4, 6, 8, 10. And it's also a really good idea for me to look at the other axis as well and make sure I know what that interval is. Again, it looks like they're equivalent or the same distance. So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay, so the question specifically asks us to try to figure out how much we're going to pay if we go 6.5 miles. And so I know that 6 miles would cost me about $15. And I know that 8 miles is going to cost me about $19. And so what I'm trying to figure out is what 6.5 would be. So I know 7 would be halfway in between 6 and 8. And I know that 6.5 would be halfway in between that. So I'm looking at about a quarter of the distance between these 2 intervals. So I'm going to track that all the way up until I bump into the line. And I'm going to notice that I bump into the line a little bit shy of 16. And so what I could do to estimate this is to say that it's going to be about $15.50 or something around those lines. All right, so that's my prediction. However, I'm going to now go over it algebraically and make sure that you understand how you could go ahead and compute this to prove whether you are right or not, or to check for reasonableness of your estimate. So we're going to follow the same format that we did with the last one. And in this case, the only difference is that they have not provided us with ordered pairs. So what we need to do first is to establish what some of our ordered pairs are. And again, we want to make sure that we're going with very exact information. So we're going to select 2 points. And to be completely honest with you guys, I really don't like the way that they're setting this problem up in the book. I do not like that we have to pull ordered pairs off of a coordinate graph that are not at an intersection of my grid lines, because at this point I'm now guessing. Because who knows whether this ordered pair right here represents 2, 7 or 2, 7.1 or 2, 7.33333. I don't really know its exact location. So it's a good thing that they're asking me to predict. So I'm going to go ahead and just do what I'm assuming they want me to do, and that's to assume that this ordered pair right here is 2, 7. That's what I'm going to call it anyway. And then I'm going to pick another ordered pair, and unfortunately all the ordered pairs that they're giving me do not fall on the exact grid lines, so I'm just going to pick another one and try to get as close to an estimate as possible. So this one's going to be over 4, up, and I'm going to call that 11. So that's my second ordered pair. Now again, I don't encourage this. I don't really like the way that this is laid out, but I'm going to go for it because it's one of our examples in our book. So the first thing that I want to do in order to write this as an equation is to recall the format I need to put it in, which is y equals mx plus b. I'm going to first start by finding my slope using these 2 ordered pairs. I'm going to substitute them into that cool formula of the change in y over the change in x. Do 11 minus 7 over 4 minus 2. Which gives me 4 over 2, which simplifies to 2. So I already know that 2 is my slope. Okay, now on this particular graph, we can see that the line does not intersect at 0, so it's not proportional. And again, we've got an intersection at about 3, but I'm not exactly sure. So I am going to take the time to crunch the numbers and make sure that my y-intercept is as accurate as it can be. And so I'm going to just randomly pick this ordered pair. And I'm going to call this my x and this my y. And I'm going to substitute these 2 numbers into the y equals 2x plus b equation that I am beginning to generate. Now remember, I got this because I just found my slope. And so I know that slope is represented by the letter m. And so I just replace the letter m with the number 2. So now I'm going to go ahead and substitute 7 in for y and my 2 in for my x. And then I'm going to solve for b. So I get 7 equals 2 times 2 plus b. And then I'm going to simplify that multiplication to 7 equals 4 plus b. And again, hopefully at this point you can see that b is 3. 4 plus 3 is 7. So I can end up rewriting this equation as y equals 2x plus 3. All right, so let's interpret what this means. This means that I'm going to pay that taxi driver $3 just to get into his taxi cab. So this is my y-intercept, and this is where my graph starts from. And so this is what we would call a flat fee. Just like if that plumber came out to our house to work on our pipes, they'd charge us a visit fee before they did any work. And then that also tells me that I'm going to pay, I'm assuming this is $2 per mile. So every mile that that driver drives, I would be paying $2 in addition. Okay, so these are some of the skills that you're going to need for the lesson you're going to work on today. And we're going to go ahead and reflect a little bit. So let's see what it asks us. It says, suppose a regulation changes the cost of the taxi ride to $1.80 per mile, plus a fee of $4.30. How does the price of the 6.5 mile ride compare to the original price? Now we could be really lazy and we could just say, oh, well, it'll be more expensive. But what we really want to be a good answer is to kind of compare the two equations and do the math and see what we end up with. So what I'm going to do first is see if you can come up with what the equation would look like. Now remember, I told you that this equation that we have here, this represents the flat fee for the ride, and this represents the amount of money they pay per mile. So let's see if you can come up with an equation for number 3, if it's $1.80 per mile and $4.30 fee. Okay, while you're working, I'm going to go ahead and write that answer down for number 5. And I know that that equation should look like y equals I think it's $1.80, 1.8x plus 4.3. Now a couple things here. Notice that I have eliminated the dollar signs and I've also dropped the zeros at the end. I want my equation to be as simple as possible. So this is the new equation, and it asks me what will happen for the 6.5 miles. How much would I pay? So in this particular case, the 6.5 miles could be substituted in here, and then I'd be solving for y, because y represents on the graph my cost. So I'm going to go ahead and take y equals 1.8. I'm going to multiply it by 6.5. Then I'm going to add 4.3 to it, and that will give me how much money I'd be spending on this particular ride. So I'm going to go ahead and do the math real quick. And 1.8 times 6.5, and yes, you are seeing me use a calculator here because I'm not working on my multiplication skills, I'm working on my linear equation skills. It's 11.7, and I'm going to add 4.3 to that. So that should be something I can do on my own without the calculator. And I end up with y equaling 7 plus 3 is 10, carry the 1, 4 plus 1 is 5 plus 1 is 6, and then 1. So this represents $16 that I would pay. Okay, so it says, how does the price of the 6.5 mile ride compare to the original price? Well, the original price I think we came up with was 16, right? I guess we didn't even get that far on the first one. So let's come back here to our first equation that we had created, which is right here. We never did end up calculating the cost of how much it would cost us to drive 6.5 miles. So let's do that real quickly. So I'm going to do y equals 2 times 6.5 plus 3. And that's going to give me y equals 13 plus 3. So this gives me $16. Okay, so what can we say about the two? How does it compare? They're the same. They both cost $16. And how can you use a graph of a linear relationship to predict an unknown value? We'll get back to that.
I will in a minute, yes. I'm going to leave in the middle of this.
All right, everybody, so we just finished number 3, and now we're going to move on to number 4. It says, how can you use a graph of a linear relationship to predict an unknown value of y? I'm going to say that again just in case you didn't hear me. Number 4, how can you use a graph of a linear relationship to predict an unknown value of y for a given value of x within the region of the graph? So I think basically what they're asking you in this case is, how do you determine what a y value is if they give you an x value? And I think you saw how I did that back here on this graph when I just tracked across. And in this particular case, they were talking about 6.5 miles. So I went to 6.5 miles on the x-axis, and I don't know what the y-coordinate is, so I just tracked up until I bumped into the line. And I was able to give a good estimate as to how much that would cost. So you can identify the x-coordinate, and then you can find the matching y-coordinate on the line. And that'll tell you what your y value is. So once you bump into that line, you should know what your y value is. And how can you use a table of linear data to predict a value? So in this case, we knew that if we were trying to figure out how to get from 480 to 3,600 and how to get from 3,600 to 5,760, or how we got from 2 to 480 and 15 to 3,600, we could figure out a relationship by comparing our x and our y. And so what we learned was that we could find the slope or the constant by doing y over x. And that would give us our constant. So that's one way that we could use a table to predict a value. All right, so it's your turn now. I want you to try number 6, 7, and 8. And as you can see, the answers are already available to you. But go ahead and pause the video and see what you come up with. And when you come back, I will show you the answers that I got, and I will explain how I got them. Welcome back, everyone. So these are the Your Term questions on page 143, and these are numbers 6, 7, and 8, and I'm going to just project them here for you. Number 6, I first picked 2 ordered pairs. I found my slope, and then I was able to determine that it was a constant of variation. It was proportional because it went through the origin. So I knew that my y-intercept was 0. So again, the preferred equation that you would want to write is this one, because it shows this equation simplified. 15x plus 0 is 15x. And then I could use that information on number 6 to determine the income worked for 2 hours. So at first I created my equation, and then I substituted 2 in for x, which is my number of hours worked, and I was able to get 30. I could have also used the chart and said after 2 hours, I made $30. That's probably the easier way, but this is more mathematically valid. And then for number 7, it asks you for 3.25 hours, and that's a little bit more tricky to establish on this graph. So even though I could come over here from 2 to 3 and then from 3 to 4, I know 3.25 is about here, I would be really estimating about how much money I earned. So again, I use that expression or the equation that I originally came up with, which is y equals 15x. And I substituted 3.25 in for x, which is the number of hours worked, and I multiplied and I got $48.75. And then finally, it says total income earned for working for 5 8-hour days. And so 5 8-hour days is 5 days, and there are 8 hours in each day, so that gives me 40 total hours. So 15 times 40 is 600. Therefore, they earn $600. Okay, we're almost done with the lesson, guys. The only thing that I want to do is to go over one more concept with you, and that is what happens when we don't always graph things that line up. And so that's where this new term comes in, that is contrasting linear and nonlinear data. And one of the ways that you're going to see that written is bivariate. So the word bivariate, if you look at it, bi means 2, variate is another word of saying variable. So this just means that there are 2 different variables. It's a set of data that is made up of 2 paired variables, like an x and a y or an a and a b. And if the relationship between the variables is linear, then the rate of change or the slope is constant. If the graph happens to show a nonlinear relationship, meaning a curve, so when you graph your data points as ordered pairs on a graph, if it curves and it doesn't create a line, then the rate of change varies between pairs and points, and you cannot write a linear equation as a result of that. So we're going to go through this briefly. I'm going to try and talk through this kind of quickly, so make sure you're taking good notes and asking questions tomorrow. It says Andrew has 2 options in which to invest $200. Option A earns simple interest of 5%, while option B earns interest of 5% compounded annually. The table shows the amount of the investment for both options over 20 years. Graph the data and describe the difference between the 2 graphs. So I'm going to call option A red, and I'm going to call option B blue, and I'm going to graph them. So the first ordered pair that I get for option A is 0, 200. And I'm going to come over here to the graph and graph 0, 200 in red, then 5, 250, 10, 300. Now make sure that you are using the right interval numbers, 15, 350, and 2400. Okay, and this actually turns out to be linear. When I connect these points, I can see by using a straight edge that they do all fall in line with each other, And so I'm just going to go ahead and connect the dots and create that line. So now what I want to do is I want to do option B. So in option B, in 0 years, this person will still have $200. They start at the same point. 5 years, $255.26. So this was 250 right here. So 255 is going to be just a hair higher than that. And then in 10 years, they're going to have $325. So again, 300 here, 350 is here, 325 is going to be right in the middle. In 15 years, they're going to have $415. So that's going to be about here. And finally, in 20 years, $530 is going to be way up here. And if I try to draw this linearly, meaning I try to make a straight line, look what happens. You can see, hopefully, that the straight line is supposed to go from one point to the other, but it would not intersect all of the blue points. So what option B shows you is that it is nonlinear. We can still connect the points because this relationship does have something to do with each other. Each point does represent something, and we could save up money for an indefinite number of years. Like, it doesn't have to be 3 years or 2 years. We could save money for a year and a half or a year and 7 months. So that's why we're still going to connect those dots, but you can tell that it curves, and therefore we just call that nonlinear. All right. So the first thing was to graph it. That was pretty easy to do. The second thing tells you option A, we want to find the rate of change between the pairs of points. Remember, rate of change is the same thing as slope. So what we're really being asked to do here is to calculate our slope, and I probably should have done that in red to have it match up with the red graph. So this is my slope, and notice that they've set it up here for you. Here's my first 2 ordered pairs, 0, 200, and 5, 250. They pulled that right from this table, and they did the change in y over the change in x. 250 minus 200 is 50. 5 minus 0 is 5. When I simplify, I get 10. What we're really doing in this chart is checking to see if there is a constant rate of change. We can tell from the graph that there should be because we've drawn a linear equation. Therefore, it's a constant relationship, and therefore our slopes should all be the same. So let's go ahead and try and do the slopes on these other ones. I'm going to do 300 minus 250, and on the denominator, it's going to be 10 minus 5. This again gives me 50 over 5, which again gives me a 10 as a slope. So far so good. Finally, I'm going to do 350 minus 300. And then 15 minus 10 is my denominator. Again, I'm still getting 50 over 5, which is giving me 10. So to answer the bottom 2 questions, the rate of change between the data values is 10. So the graph of option A shows a linear relationship. And again, like I said, that's kind of obvious because of what we've drawn. So now we're going to move on to the next page with the option B. And we're going to see what happens when we go to compute our rate of change. So in this particular case, we are going to do the same ordered pairs that they gave us in the chart on this side. But remember, we're using the x value here and then the y value in option B. So that's how they're generating their ordered pairs. And so for the first one, it's 0, 200 and 5, 255.26. And if I subtract those, I get 52.26 over 5. And again, I don't really want you to do these computations mentally or on paper. You're more than welcome to use a calculator. So 52.26 divided by 5, and that gives me 10.452. Now this doesn't really mean anything until I calculate my other rates of change, and if they're equal to 10.452, then we still have a linear equation. But if they're different than this slope or this rate of change, then we know it's a bivariate relationship and it's nonlinear. Okay, so what we're going to do here is we're going to take our next set of ordered pairs. I'm going to do 325.78 minus 255.26 as my numerator, and my denominator is going to say 10 minus 5. So I know my denominator is going to be 5, and then I'm going to do 325.78 minus 255.26, and I get 70.52. Now, I can just tell by looking at the two divisions. This gave me 10.452, So when I take a different number and divide it by the same divisor, there's no way I'm going to get the same quotient, but I'm going to show you what that answer is anyway. Divide that by 5, and I get 14.104. So already at this point, I can tell that my rate of change isn't constant, but I'm going to finish this up anyway. So last one is 415.79 minus 325.78, and that's going to be over 15 minus 10. So again, my denominator is still 5. My numerator is 90.01. And when I divide that by 5, I get 18.002. So the rate of change between the data values is not constant. So the graph of option B shows a non-linear relationship. Okay, so here are the reflection answers. Because this video has been quite long, I'm going to go ahead and sign off for today. I encourage you to read over my answers for the reflection questions and put it into your own words, make sense of it for yourself. Bring any questions you have about any of this to class tomorrow. And you're going to eventually be working on the guided practice and independent practice all for these lessons. So if you have questions on that as well, let me know. Good luck with everything tonight, guys. We'll see you in class tomorrow.